Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. In previous sessions already we have discussed about the engineering typology subject. So in this subject we have learned the various parameters like friction, wear and lubrication and corrosion related topics. And then the engineering materials also very important in this engineering typology. So the selection of material is a very crucial part in Indian typology subject. So already we have studied the theory part. So now in this session, so I want to discuss about the questions, the tutorial questions related to this engineering materials. How they will ask in examination, we will learn in this session. So the topic is titanium alloys. So related to this titanium alloys, so what are the important questions and then answers we will discuss here. So explain types of titanium alloy and the list out the advantages. So directly they will ask, so titanium alloy, how many types? So many types are there in titanium alloy and what are the advantages of the titanium alloy list out? Well, 2-3 points you have to write in the examination. So the advantages and then types also you have to write very briefly. You have to give explanation very briefly. The types of titanium alloys are, one is commercially pure titanium, that is CP. So the grades are in this 1, 2, 3, 4 grades are there. And the composition is essentially pure titanium with minor amounts of oxygen and iron. So the minor amounts of oxygen and iron having this titanium alloy. So the pure titanium mixed with this oxygen and iron alloys. So that's why this material is called titanium alloy. So alpha alloys, next second category, alpha alloys. So alpha alloys grades are titanium 5Al and 2.5 Sen and aluminum and tin, and then Ti8 aluminum, 1MO, 1B, vanadium, titanium 6 types of aluminum. So like this the grades are there. The composition is primarily aluminum. Is the material is the base material is aluminum and tin with traces of other elements like molybdenum and zirconium. So see here you can see the molybdenum and zirconium. Here also zirconium and molybdenum. So these two are added to the base metal of aluminum and tin. So alpha beta alloys. So the grades are given like this. The composition is a mixture of alpha and beta stabilizers like aluminum, vanadium, tin, zirconium and molybdenum. Then explain types of titanium alloys and list out the advantages. Next one is in this category alpha alloys and pure titanium, commercially pure titanium alloys and alpha beta alloys, and then beta alloys. The grades are given, and then in this tin, titanium and vanadium, ferrous and aluminum added. The higher amounts of beta stabilizers like vanadium, chromium also added, and zirconium, molybdenum and zirconium. The advantages of titanium alloys are, one is high strength to weight ratio. The titanium alloys have excellent strength while being significantly lighter than steel. And then one more property is corrosion resistance. So high resistance to corrosion in various environments, including sea, water and acidic conditions. So having these titanium alloys, high resistance to corrosion, so wherever these materials are exposed to sea, water environment, and whenever acidic conditions are present, so they're having resistance to withstand these various environmental conditions. Next one is biocompatibility. So in biocompatibility, non-toxic and compatible with human tissues, making them ideal for medical implants. These are the non-toxic. So compatible with human tissues without giving any chemical reaction. It can this material easily bonded with human body parts like dental implants and bone replacements treatments. So high melting point, capable of withstanding high temperatures, making them suitable for aerospace applications. So widely used in aerospace applications, due to this high melting point property. And also important thing is fatigue resistance. The superior fatigue strength compared to other metals, which is crucial for components subjected to cyclic loading. So wherever when a component is subjected to cyclic loading, so that it means the repeated loads. Whenever the component is subjected to this repeated load, so due to the yield strength, the component will fail after a certain number of cycles. This phenomenon is known as fatigue property, the fatigue phenomenon. So the mechanical components very important this fatigue property, the fatigue phenomenon. So that's why in mechanical engineering, the fatigue testing mission is used to find out this fatigue strength before selection of material, before using and before manufacturing the product. So these titanium alloys having this resistance compared to the other materials. Next one, creep resistance. So it is a good resistance to creep at high temperatures. So maintaining strength and then stability under prolonged stress. So good resistance having the keep at a high temperature due to this creep resistance. So what are the applications of titanium alloys? The titanium alloys applications are one is aerospace, aircraft frames, jet engines, space exploration vehicles due to their high strength and low weight, and in medical field implants, prosthetics, surgical instruments because of their biocompatibility and non-toxic nature. And marine, the submarine components, ship parts and offshore structures for their excellent corrosion resistance in seawater. And the chemical processing, equipment exposed to harsh chemicals such as heat exchangers and reactor vessels. So the automotive in field, high performance automotive parts like exhaust systems and engine components. So these are the main applications of titanium alloys in various sectors like aerospace, medical and marine and chemical processing units and automotive structures. So in case of aerospace applications, the aircraft components made with this titanium alloys. So mainly engine parts, airframes and landing gears. In aerospace application, engine part and landing gear are very important due to their high strength to weight ratio. The titanium alloy materials are used to manufacture these two components. And corrosion resistance and ability to withstand high temperature. The spacecraft, their lightweight and strong properties make them ideal for spacecraft structures and components. Next one is the medical applications. One is implants and prosthetics titanium alloys are biocompatible, meaning they are not harmful or toxic to living tissues, making them ideal for surgical implants like hip and knee replacements, the dental implants, and prosthetic devices. So that's why these titanium alloys are used in this the implants, dental implants, and the medical implants like the bone replacement. The surgical instruments, these alloys are used to make surgical tools because of their non-magnetic and resist corrosion from bodily fluids. So that's why these titanium alloys are used in these surgical instruments. In the case of industrial applications, the chemical processing equipment, due to their excellent corrosion resistant, titanium alloys are used in chemical processing plants for tanks and heat exchangers and piping systems. So all these are made with this titanium alloys due to their corrosion resistance property. Whereas in power generation sectors, they are used in components of power plants, including nuclear power plants, due to their ability to withstand high temperatures and corrosion. So in the case of marine applications, marine hardware and offshore structures. So titanium alloys are used in the construction of ship hulls, propeller shafts, and other marine hardware because of their resistance to seawater corrosion. The offshore structures are there are also used in offshore oil and gas rigs for various structural components. So these are the marine applications. In case of automotive applications, see the titanium alloys are used in manufacture of high performance automotive parts such as engine valves, connecting rods, and exhaust systems due to their strength, lightweight nature, and resistance to high temperatures. The sports equipment, golf clubs, and bicycles. The lightweight and strong properties of titanium alloys make them ideal for high performance sports equipment, including golf clubs, bicycle frames, and tennis rackets. So these sports equipment made with this titanium alloys. So due to the lightweight property, and one more thing is a strong strength, a strong property of titanium alloys, and it gives long life. It means high performance. The consumer electronics like laptops and mobile devices also made with this titanium alloys are used in this casing of high-end laptops and mobile devices to provide strength and durability while keeping the weight low. So due to these properties, that's why used in consumer electronics goods and sports equipments and wherever required high performance parts in automotive applications. Next, jewelry and watches. Titanium's aesthetic appeal, lightweight nature, and hypoallergenic properties make it a popular choice for jewelry and watchmaking. So, due to this appearance, the good appearance of this material, they are widely used in this jewelry making and watches making units. So, what is the difference between alpha and beta alloys? Next question is alpha alloys and beta alloys. So titanium alloys are classified into different types. So in the alpha and the beta is one classification. The composition ways vary. The alloying elements are in this alpha alloys typically contain elements like aluminum and oxygen which stabilize the alpha phase. These alloys may also include small amounts of beta stabilizers like vanadium or molybdenum, but not enough to form significant amounts of beta phase. The microstructures is phase, predominantly alpha phase, that is hexagonal close packed crystal structure. Next one is stability. The alpha phase is stable at a room temperature and up to relatively high temperatures. The properties are strength, generally lower than beta alloys, but can be improved with alloying and heat treatment. The ductility, higher ductility and toughness compared to beta alloys. And also corrosion resistance. The excellent corrosion resistance having this alpha alloy, especially in oxidizing environments. Similarly, creep resistance, good resistance to creep at high temperatures. So, what are the applications? The applications of these two alloys, alpha and beta alloys, high temperature applications. Due to good creep resistance, they are used in applications like jet engine components. So, due to this creep resistance property. Similarly, aerospace and marine used in airplanes, landing gear, and marine applications where corrosion resistance is critical. Aerospace and marine applications. So, whereas in beta alloys, composition is beta alloys are rich in elements like vanadium, molybdenum, and then niobium and chromium, which stabilize the beta phase. And then microstructure phase is predominantly beta phase. Body centered cubic critical system, crystal system, BCC. Whereas in alpha, here, hexagonal closed packed crystal structure, here, HCP, HCPC. This is the structure, crystal structure. In this, whereas in this case, beta, body centered cubic crystal structure. Stability, the beta phase is stable at high temperatures but can transform to alpha or alpha beta phases at lower temperatures. Next, properties, strength. The beta alloy is also having strength, high strength compared to alpha and alpha beta alloys, especially after heat treatment. Next, ductility property, lower ductility and toughness compared to alpha alloy. Corrosion resistance, good, but generally not as high as alpha alloys. The corrosion resistance is good, but when compared to the alpha, so not as high. So the workability can be heat treated to achieve a wide range of mechanical properties. This is that is the workability. The applications are high strength applications used where high strength to weight ratio is essential, such as in aerospace fasteners and landing gear. So wherever required, the high strength to weight ratio, there these materials are used. Next, medical devices. So used in surgical implants and other medical devices due to good biocompatibility and strength. Already we have studied in previous materials properties, the biocompatibility property and strength property. So due to these two properties, it gives strength and durability, and also compatibility with the human body component parts. So these are the main applications of beta alloys. So explain various properties of ceramics. Ceramics hardness, brittleness, and strength. So in this, the mechanical properties, hardness, generally very hard material, which make them resistant to wear and abrasion. So generally used in these materials, used in cutting tools and wear resistant coatings. And similarly, brittleness property. The brittleness ceramics tend to brittle. It means they can fracture or shatter under stress without significant plastic deformation, without giving any indication, like in a ductility property, the breakness, the failure will be occurred. So this limits their use in applications where impact resistance is required. Next, strength. The ceramics can exhibit high compressive strength, but are often weaker in tension and shear. The strength ceramics can vary significantly based on their composition and microstructure. Next, elasticity property. Ceramics typically have a high modulus of elasticity, meaning they are very stiff, do not deform easily under load. Similarly, having thermal properties like one is high melting point, thermal insulation, and thermal expansion. So, these materials have high melting points. So that's why it is suitable for high temperature applications like furnace linings and other thermal barriers. So thermal insulation, many ceramics are excellent thermal insulators due to their low conductivity. So this makes them ideal for use in applications requiring thermal insulation, such as heat shields and insulators. Similarly, thermal expansion. So low coefficient of thermal expansion having these materials. So do not expand or contract significantly with the temperature changes. So electrical properties, having electrical insulation property and piezoelectricity property and semiconducting properties. In electrical insulation, many ceramics have good electrical insulators, making them useful in applications such as insulators in electronic and electrical devices. In case of piezoelectricity, so generating electrical charge in response to the mechanical stress. So generally used in sensors, actuators, and then the transducers. The semiconducting properties are some ceramics like silicon carbide, certain metal oxides can exhibit semiconducting properties are used in electronic components. So chemical properties, corrosion resistance, and having inertness property. These ceramics are generally highly resistant to corrosion and chemical attack, even at high temperatures. This makes them ideal for use in chemically harsh environments, such as chemical processing equipment and medical implants. Similarly, the property is inertness. So having the inertness property do not react easily with other materials. The physical properties, the density and porosity. The density of ceramics can vary widely. Some ceramics are very dense and heavy, while others, like formed ceramics, are lightweight. Porosity. So the ceramics can be engineered to have varying degrees of porosity, from fully dense to highly porous. Porous ceramics are used in applications such as filters and catalyst supports. So next, optical properties. So having transparency and opacity, and then refractivity property. Some ceramics like certain glasses and sapphire can be transparent and translucent, so making them useful in optical applications such as lenses and windows. So other ceramics materials are used in applications where transparency is not required. So they are similarly refractivity material property. So the ceramics can have high refractive indices, which is beneficial in optical devices like lenses and prism. So these are the references I have taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.